And without further ado, I'll introduce Rick.
Well, good evening, everyone. My name is Rick Ross. I'm on, right? Oh, thanks. I haven't even started. So my name is Rick Ross. I'm an advisory platform architect with Pivotal. And I'm kind of curious to gauge the audience to see your understanding about containers. So how many people here could maybe say what a container is? I'm not going to actually ask you to do that. So a few of you. All right. What about, do we have mostly developers here, ops? I've heard some DevOps people in the room. So if you're a developer, okay. Operator? DevOps? I mean, I know that's sort of all blends, right? Okay, cool. Just want to gauge what we have here. So tonight, what we're going to talk about is what is a container, right? For those that aren't aware, I want to explain what a container is because, you know, there's all this stuff out there, and when you think of containers, who do you think of? Docker, exactly, right? Well, the history of containers is a little bit further back than Docker, right? So then we're going to talk about what are we really trying to solve with containers, right? So I'm going to take a step back and get a little philosophical with you. And let's talk about what containers are really good for, right? Then we're going to talk about actually how do you build and run a container. And this is going to be a local using Docker, right, on my laptop. And later on, if we have time, depending on how we're doing on time, I'm actually going to show you how to deploy containers into Fargate on AWS. So we're going to talk about specifically the options for containers with AWS. There's quite a few, actually. And I was quite surprised myself going through and researching this. So we're going to specifically focus on Fargate. Then we're going to do the demo that I mentioned before. We're going to talk about use cases, what use cases are really good for containers, and what use cases may not be the best use cases for them. And then we're going to wrap it up with options for managing containers. Sound good? All right, so here's the technical definition that I created. I looked for a formal definition of what a container is, right, on the internet. And I didn't like what I found, so I created this. But really, how I like to describe containers is just like we went from bare metal to virtual machines to be more efficient, right? We now take a virtual machine, or even bare metal for that matter, and we can carve it up into containers, or an isolated area or segment that allows you to run things within it. And it doesn't give you that noisy neighbor problem where you have one application that's consuming all the resources, right? So containers are really good for isolating things like your CPU usage, your memory, and networking. Make sense? So what does this look like visually? So here is your physical hardware. Now this is set up to use virtual machines because typically we're seeing that more in the industry today, right? We're trying to put software everywhere because it's a lot easier to automate and manage. So your physical hardware layer, moving up, you have some kind of hypervisor, right? Whether that's VMware or Hyper-V or Xen, doesn't matter for the sake of containers. Once we can create virtual machines, right, then we have some operating system. Prior to Windows 2016, the only way of doing this was on Linux, right? So Linux really is where containers came from. And we'll talk about that here in a bit. But the important part here is that each container, right, is using the same basic underlying operating system. So that that gives you some challenges that you have to deal with later, we'll talk about. But in order to run multiple containers, you need some kind of container management system. And there's a bunch of options out there. All right, so visually, this is what containers typically look like. And again, the virtual machine, I just use that because of this notion of software-defined data centers and so forth. So if we take a look now at the history, where containers came from, right? It's a pretty old technology. Granted, this wasn't containers down here, but it set the basis of this. Down when we're doing Chroot, I think is how you pronounce it, right? So we went from Chroot to jails to control groups, right? And then we got to LXC, which is really where containers really got its name from, LXC, right? And I was talking to my son, he works at Facebook, and he was telling me that's what Facebook uses for their container system. So it's kind of interesting to see how some of this technology is still being used today, where we have things like Docker and even Cloud Foundry, right? So there's a lot of technologies out there that give you the ability to isolate your applications and prevent that noisy neighbor problem. The other thing that's interesting too, in 2015, the Open Container Institute was formed, right? And so what they were all about is, it's like, okay, we don't want to just have containers be locked into a specific vendor, right? We want to come up with a standard, a specification of what it means to be a container and how to run containers. And so you've got a bunch of companies that went in together, Docker, Pivotal, IBM, AWS, and, right? I'm not going to name them all. You can go on the website and find it. But what they did was Docker donated Run C to the community.
Thanks. Are you saying that the specifications or the understanding of what a container wasn't specified well enough, so they just couldn't take and use what was existing? They had to create a new set? That
sort of, yeah. I mean, they wanted that portability, right? And it wasn't quite there. And in order to have that, guarantee that portability, they founded the OCI.
Wow.
Make sense? So containers, there's a lot of great benefits for using these, right? They're small and lightweight. What does that mean? So that means I can start up a container in milliseconds compared to a virtual machine, which probably 10 seconds, maybe a little faster, right? So they're a smaller footprint too. So I don't need to have all hundreds of megs of operating system to load up. I just have maybe tens of megs of software to load up, right? They're also faster startup, right? Better utilization. So now I could be more efficient with my hardware. So I can compact more on a box or inside a virtual machine. So I could do more with less. What business doesn't want that, right? Isolation, resource sharing, we talked about. But really, I think the most important part here is that they're really the underpinnings of how to be elastic. They have all the things you really want in order to build an elastic system. And we'll talk about that later, what that looks like. So containers are really important, but it's only one piece of the puzzle. What they solve is that isolation. So what else do you need in order to actually take a container and put it in production, right? So you got to be concerned about security. Every company has got security on their minds today, right? It seems like every other day there's another hacker who's gotten into some company and lost, information's been shared out. So how do you actually secure containers, right? How do you create the containers? What's the process behind the scenes? Not necessarily a technical one, but talking about culture and process that you have. How are you going to manage the images? So containers, actually, there's what we call an image that reflects what's inside the container. And we'll see this here in a bit, right? So I've got this image. Now what? What do I do with it? Container orchestration. So when you're talking about running a container on a laptop, that's really easy. Docker run, boom. And we'll see this here in a little bit. But when you're talking about a system for a large enterprise, right, I need to understand where my containers can run, because I'm going to have multiple endpoints, if you will, of where containers can run. So how do I know where my containers need to be? Right, that's container management. This next one, critical vulnerabilities and errors, CVEs, right? What was the latest security concern we've had, right? Is Spectre and what's the other part? Meltdown, right? That affects everything. It's crazy. How do you actually upgrade the operating system when there's a vulnerability, right? What's the process you do? Since now we've got multiple containers sharing a virtual machine with the same operating system, how do we do that, right? So it's not a trivial problem to solve. networking and load balancing. So how do you make sure that you have a system that I have traffic that can get to the right container? And I can load balance when I have multiple containers running the same application. How do I make sure the traffic goes where it needs to go? Service discovery. How do I know where those services are even located on what container, right? So you can see there's a lot of things that you really have to do. Log management's another one. You've got containers that are writing logs out. Where do the logs go? Do I have to go on each container to get the logs to debug my application? I hope not. That's kind of crazy. And then monitoring. How do you make sure your containers are up and running? So my buddy Boromir says this. One does not simply from a Docker container without load balancing and orchestration. Probably did a terrible job with the accent. My apologies to Boromir and the actor who actually does this. But it just goes to show what you need in one aspect of what you need in order to run containers. And then another one is one does not simply deploy containers into production. Containers aren't enough, right? That's not to say containers aren't good, right? They just require a little bit more stuff. All right. So that's really, in a nutshell, what containers are, and give you an idea of the challenges you have if you're dealing with containers. So let's take a step back and ask a more philosophical question. What problem are we trying to solve with containers? Right? And unless somebody, if somebody has an answer and wants to, bring it forth, we could pass around the box. But what's the problem we're trying to solve? Right? Are we deploying a web application? Are we deploying maybe some software that a vendor has shipped to us in a container? Or maybe we're shipping software to our customers in a container, right? What exactly are we trying to solve for? And so when you start to think of the different workloads that enterprises deal with, right? From containers to batch to monolith. By the way, the way we've been doing software development over all these years, big application with everything in it is now legacy, and they call it monolith. It's kind of funny. There's nothing wrong with monoliths. They work. There's challenges behind it, but that's a time for a different subject. Data services and microservices. This is where we're seeing a lot of our customers at Pivotal head towards is microservices. Anybody here doing microservices in their organizations? Okay, cool. So you have all these different types of ways to run workloads, all right? So we need to pick the right tool for the right job. So there's going to be some times when you want to have a container orchestrator to actually deploy a container. So the developer brings to you the container, and then it says, hey, container orchestrator, handle this for me, right? But sometimes we just want to deploy an application, something like a web application that does some functionality. Maybe we're exposing some endpoints for a mobile phone for our customers, right? Why deal with a container when you can deploy an application? And it handles not only the container orchestration, but all these other concerns that we have. And then sometimes we want to do some respond to an event, right? And we only really need to deploy a function. Why would we deploy a whole application when we could just deploy a function to handle, right? So we want to pick the right tool for the right job. Now, as you do that, we have these different levels of abstraction, right? As you work your way up from hardware to IaaS to container to application platform to serverless functions, there's some trade-offs. So as you move up the hierarchy, you're really constraining what your developers can do. But the benefit is, and you could actually see that as a benefit, depending on your view of that, the operational concerns become much easier to handle because you know the unit of deployment you're dealing with. If I'm deploying a function, I know it's in a Lambda or Pivotal Function Service or, right? If I have an application, I'm just deploying a jar file, right? If I have a container, I'm going to use a container orchestrator. So you have to think about the trade-offs of what you're trying to actually run and where it makes sense. Now, the flip side of this is that the further down is where you have more options, right? And what happens is you start to introduce snowflakes. And for anybody in operations who's been around for any length of time knows that problem. When somebody says, hey, I want a request for some servers, well, what do you want to do with it? And it's not the same thing as what you've already been doing from one project to the next. Introduces snowflakes. And it makes for some operational challenges, right? So really think about what you're trying to deploy and what makes sense. And it's not like I'm saying always deploy applications or always deploy events, because let's be realistic. If you take a look at an enterprise app, how much of a typical enterprise app really could be handled by serverless functions? Not much. Not much. I mean, depends on the domain. It depends on what you're doing. But for the most part, you're going to have a very little piece that will be deployed as functions. So does this make sense? All right. So that's what gives you an idea of how to look at this from the problems that we're solving. So next, let's take a look at what does it take to actually build and run a container. So here I've got a sample Docker file, and I'm deploying a Java Spring Boot application. Anybody here know what Spring Boot is? If you're doing microservices and you're not using Spring Boot, you might want to check that out, because it's probably the fastest and easiest way to do microservices, especially if you're a Java person. So the Docker file is specifying what it needs inside of it in order to run the application that you're deploying, or whatever it is you're running in the container. And in this case, I'm running a Spring Boot app. So the from line is saying, that's my base source image, OpenJDK 8-JDK-Alpine, right? So there's an image up on Docker that corresponds to that label that gives me a Java JDK on it, which is cool. I need that in order to run a Java app. The add is taking my local jar file and changing the name to Echo and putting it in the target folder in the container. Then I'm setting an environment, the Java ops to nothing, just the empty string, and I'm exposing port 80. And then the last piece is, how do I actually start my application, right? So that's, for those that aren't Java gurus, this is just think of it as the start command to do it. Okay, make sense? So what happens, you take that Docker file, you do a Docker build -t, give it a name, and a dot for the current directory, and it produces a Docker image. And the Docker image contains a root file system. It contains some configuration, like environment variables and so forth. It contains a manifest, which is more about the metadata, and then the application itself. Once I have this Docker image, I can then do a Docker run, and here I'm specifying what local port I want to use, and what port inside the container to map that to, and then what container image I'm running. So that's really the way you do deploy a Java application. So similarly, if you wanted to deploy PHP, you have to do some of the same similar things. Instead of getting a JDK image, we're getting an Apache PHP image. We're copying some source to the right folder in the container. We're cleaning up the index.html because we want to run just the PHP. And we're exposing port 80, and then we're starting Apache, right? And then we do our Docker build, Docker run. Does this make sense? Well, we'll actually walk through this here in a bit. Just wanted to give you a kind of a visual of what this looks like.
Here, the command is similar to the entry point in the last one?
Yes,
okay.
That's correct. All right. So we've talked about containers. How do we actually use these within AWS, right? And there's a lot of options. You can have your choice between Fargate. So Fargate is probably their most recent offering when it comes to containers. And it makes it so you don't have to deal with the underlying infrastructure to a higher degree. I'll walk through this, and you'll see the types of information you need to supply, but it's not as deep as if you use Elastic Container Service itself. Where Elastic Container Services, you're going to have more control over the size of your virtual machines that you're using, for example. EKS is in preview, so I didn't have a chance to play with that. The other option here is you can roll it yourself. I would not recommend that, though. There's lots of tools out there to do this. Don't do it yourself. You know, there's open source stuff out there if you don't want to pay money, right? But there's also commercial products that do a great job here. And the options there for if you want to roll it on your Docker Enterprise and CoreOS, and probably anything else out in the community. But these are specific that you can get from the marketplace or straight from Core. All right, so let's take a look at a demo. All right, so I'm in my Java Echo folder, right? So I've got my Docker file. Let me just show you that. And it looks just like what I showed. So now I'm going to do my Docker build, and I'm going to cheat and just go up to my Docker build, so I don't have to type it in. And this is going to go really fast. Now, the first time you run this on your box, it's going to take some time to get certain things and do what it needs to do. Once I build it, I can then do my run, and it's going to launch my Spring Boot application. I'm going to wait for this to actually start to listen for information. Then I can bring up my browser and go to my localhost. And I see, hello, AWS Meetup. Hoo-ha. This is a very simple REST Java Spring Boot application, just to show you what's possible, right? So now let's actually see what it's like to actually deploy something on AWS. So hopefully I didn't get logged out. So I'm going to go to my Elastic Container Service. Yeah, okay, thank you. I must not be logged in. Here we go. Oh, so there's two ways to do this. This was a little frustrating to me. I'm not an AWS guru. I'm going to be the first to admit this. But you can go through this way, but you can also go through the console that I'm trying to get back to where I was earlier today, and that is bizarre. Yeah, I know. That's like it's not console home. No, that's not EC2. Elastic Container. It's like it changed. It seems like it changes every time I go back.
Try that Get Started button, the blue one. It might skip you past the little welcome to. Oh, it's taking you to the toot.
Yeah. What happens if I hit cancel? Because here we go. This is what I want. All right. So what we got to do here is start it with. You don't have to, but I'm going to start with the repository. So I'm going to create a repository. I'm just going to call it AWS Meetup. I'm going to grab this URL because I'm going to need it later. I should have brought my other mouse up here. Make it easier to cut and paste. Next. And what this is going to do is it's going to set up what I need to do in order to push my Docker application. So I'm going to go back to my command prompt, switch over to my PHP Echo, and this gives me a Docker login. Please don't memorize this. Good luck if you can. But this is pretty nice because they go through the steps, and basically you're just going through doing a copy paste to actually set this up. So what this is doing is it's make sure my Docker container is built. That's what that previous command is doing. And now I'm going to tag it, and now I'm going to actually push it up to the cloud. And so now it's going to take and upload all the bits to my image repository. So this is one of the things you need when you start working with containers, is where your containers live. a container repository. So to make it easier, I'm just using AWS's repository. You could also use Docker Hub or private repo on your own on-premise environment as well. Any questions while we wait for this to finish? I thought about just having this done before.
Thanks. You
Yeah.
mentioned money earlier, like, not wanting to waste it and that kind of stuff. Like, are containers super expensive? I've kind of heard they're not too pricey, but if you're getting started with this and start putting a bunch out there, like, and costs getting out of control quickly?
Well, it depends on containers themselves. No, I mean, you could do Docker for free on your laptop. It really depends on how you're going to manage your containers and what you choose to use. So, and what's your distinction for expensive? Like, it might be $1 million is too expensive, but $100,000 isn't. I'm just throwing out numbers, right? Depending on the organizational size. So, it's what you're probably going to find. You're probably going to have more in operational costs, maybe managing it than the actual infrastructure and stuff over time when you look at it over a longer period of time. So, does that answer your question? I feel like
I'm just curious.
Okay.
The containers don't belong to a free tier, do they, on AWS right now?
No, I don't believe they do.
It's a paid
Yeah,
tier.
right. So we'd have to figure out how to see what this is actually costing me. But I clean up after each time I do this, so I start over from scratch, and it's probably a couple bucks,
Yeah.
right? It's not a big deal. This is taking a lot longer.
So in terms of cost, even development costs seem like they would increase. In terms of costs, development costs seems like it would increase to prepare.
Prepare a container?
Yeah.
Yeah, absolutely. That's a great point. And that goes back to the abstraction story, right? So if in this case I have a Spring Boot application, why would I create a container for a web application, right? That would serve better in maybe a Beanstalk, or I'll plug my own company, Pivotal Application Service. We'll talk about that later. It goes back to what do you want to manage and why? And if you really have that complexity, and we'll talk about this, when it really makes sense for to use containers, right? We'll talk about that later. But you're right. When you have developers who have to actually understand Docker, right? What all the bits that need to go into the container, right? Now, it's like any new technology. There's that initial learning curve that's kind of crazy, but once you understand it, it's a lot easier, right? So it's trade-offs. It all comes down to trade-offs. If you need that flexibility, containers is the way to go, plain and simple. But if you can move up the abstraction and deploy just an application, that helps free up developers to do other things, right? Come on, baby. Sure.
So you're building the container, and it runs in a virtual machine, shared an underlying OS. All right, so that underlying OS is being hosted for you on Amazon. And what flavor? I assume it's a Linux. Do you know if it's a flavor of Linux or?
Yeah, it is. I don't know actually what Fargate is using under the covers. If I had a guess, and this is a complete guess, would be Ubuntu, but it might be something else. It's certainly going to be something that they don't have to pay money for. Or it might be Amazon's own version of Linux. That might be even more likely, right? Because they have more control over that. Next time, note to self, do this first. Don't wait for the push to complete. Any other questions?
So just going from there, I'm following up to people's questions. So it's not Windows, right, ever? Or is it sometimes Windows?
Great question. So Microsoft finally got their act together in Windows 2016, and now there's true containers, true containerization, right? They're actually using Docker technology. They worked with Docker to do this. Yeah. So yeah, you can actually do containers on. Come on.
Buy Docker actually for billions and got shot down, so now they haven't made it back. And that's when that Docker technology got integrated into 2016, just because of that code development.
Yeah, so the gentleman was talking about the code development between Microsoft and Docker to bring that technology into Windows.
And I'm not sure if you're gonna talk about this later, but can you do what you're doing here with the Windows containers, upload it to Amazon's?
I don't know if Amazon supports that yet.
Okay.
I mean, the Windows containers is relatively new.
Yeah.
Pivotal's product for supporting Windows containers, 2016. We do it with 2012 in a the best we could do with what the operating system gave us in the next release, which is due to drop this month.
Azure would support it.
Yeah.
It's at least in preview. I don't know
Right.
if it's gone out of preview yet, but
Absolutely.
I don't believe Microsoft actually, or AWS supports I don't believe AWS actually supports the Windows containers, because if memory serves me correct, you have to run with the Hyper-V extensions. You might be able to get away with it, get like one of their bare metal boxes, and then load a Windows image on there, and then essentially load Hyper-V and do it that way.
Yeah, that makes
you'd have to
sense.
put it in EC2 probably and load it that way.
Yep.
It'd be a lot of
Oh,
layers
yeah.
at that point.
Was there a comment and question?
I had a question.
Here.
Did I hear you say that if you can load the application, then there is really not a necessary need to do a container?
Yeah, in the example that I
Yes.
just did, it was a Spring Boot app. It's a web app. It's
Right.
running. It's listening on whatever port I tell it. In this case, it was listening on.
So if you're running a Nginx or running a JavaScript app on Node.js, then is there a need to do a container?
Well, it depends on the trade-offs. So if your choices are to use a container versus push an app, what would you prefer? I mean, developers, it depends on your level of expertise. Some developers say, let's just build a container. Others say, I don't care about containers. That's an implementation detail. I want to just deploy my apps.
But in a Node.js app, all you're doing is just loading up the app files, and everything else is already on the EC2. So I'm trying to figure out, why would you then need a container there?
Well, again, so I'm gonna jump, since I have time, we'll just move forward. So when you start looking at your application design, web applications really aren't that complex, right? They start up, they're listening on a port, they're getting requests, they're sending data back, right? When you start doing things that are listening on multiple ports, or are more, maybe require specific hardware, maybe some GPU intensive work, that you have the underlying hardware to support it, that's when you could start looking and say, you know what, the complexity is much more than a web application. Let's put that in a container. Or I have all these bits and pieces that make up this application, and I want to deploy them as a single unit. Might make sense to put them all in a container.
I also think one thing about the developer experience is that even if you're not going to deploy it with containers, sometimes it can make your life a lot easier to develop with them. So your environment can be completely repeatable and shareable with new people
Yep.
joining your team. Like all your tools and all of
Yep.
everything is there. They don't have to get their operating system in gear and install all the dependencies. So that can be a benefit. You might use it but not deploy it that way. Sometimes it'd be nice to have like your whole dev database just containerized, so you can just like knock it out every time you need it and start from scratch. It's nothing you couldn't do with Node and the command line and MySQL on your local machine, but sometimes it makes it a lot easier because it's rock solid repeatable,
Yep.
and you know you can get back to zero, and you can share it with people, and you can version control the instructions that will get you back to that exact point, which
Yeah.
which can be handy.
Exactly. You stole one of my lines.
Oh,
from the-
sorry.
No, it's great. I'd rather it come from you.
You can use something like Docker Compose to bring up sort of your full sort of stack.
Yeah.
For local development.
Yeah, do it all the time.
Yeah.
Like if I have an app that may not be too complicated to deploy, but I need Elasticsearch and MySQL along with my development environment, it's just sometimes very easy to just like bring them all up together and then put them to sleep and go away. you know?
Right. Yeah, absolutely. So I don't know if the network's agreeing with me here today. So I'm going to go back to the deck. We'll come back to that after it finishes. So let's actually now talk about use cases. We've touched on this already, right? So when you take a look at what the industry recommends containers for, local application development and testing, right on, right? We just talked about that, and this the problem we used to have prior to containers, right? We were setting up a new development team, and we need a certain version of Java or a certain version of Microsoft Studio and all these other bits just to be productive, right? So what we could do is put all that in a Docker container, and now we just pass the Docker container around, and developers can actually work inside of a container on their laptop. And the nice benefit of that, if they screw up the container, they start over from scratch. So that's a great use case. Distributed applications and microservices. You probably see this as probably the biggest push for containers. Distributed applications and microservices. I have a different opinion personally because I work for Pivotal, but this is a valid use case. When you have a good container management system that can handle the details that you need at an infrastructure layer, as well as, from an operational standpoint and developer productivity, right? Another valid use case. Batch ETL jobs, right? Those seem to, seems like they've been around for years, and I don't know if they're going away anytime soon, right? Especially if you've been in a company that's, 7 years or older, you're probably running into batch jobs. just the nature of the beast. CI/CD, really, really powerful. Everybody know what CI/CD is? So for those that don't, this is really a fundamental premise of Agile. If you want to go fast doing software development, you should be doing CI/CD. And what this looks like is, as a developer, I'm writing code, and then I've got something, I'm ready. So I check it into my source code repository. Once I do that, that kicks off a series of things. It's going to build it, it's going to run some tests on it, and it's going to create an artifact. Usually you store that artifact like a jar file or the bundle, the tar that you need for your PHP application. And it's going to store it in something like an artifact or a Nexus, or maybe even a file system. Really just a place to store that binary to have. Once I have that binary, then I want to deploy it to my environments, right? It might be QA, and depending on how sophisticated your organization is with software development, it might be multiple environments. At some point, you want to get it to production. But in the CI perspective, you don't go to production. You're just continually, you're getting it to a point where you're doing all the integration tests where you could deploy to production if you want. There's usually a human involved to say, there's enough value here to deploy to production. Does that make sense? Any questions there? Feels like this is falling off. Stateful applications. So typically containers are ephemeral.
Your cable is wrapped around right by your mic.
Oh, thank you.
Yeah.
Thank you. So typically in a lot of places containers are ephemeral, meaning they go away, the actual underlying operating system. So you can't rely on the hard drive in that container to stay around if it stops. So that's called ephemeral. They're ephemeral. So you typically, if you want to persist state, you attach a volume of some kind and make sure you write into that place, into a volume rather than the container itself. Now, stateful applications are a challenge. In the cloud native world, I'll throw a term out there. We're not going to have time to dive into cloud native. That could be another whole session. It's a term out there to describe a new way of doing software development that enables companies to go really, really fast. And it's microservices, DevOps, containers, and there's one other, CI/CD, right? So in the cloud native world, you want stateless applications. It just makes it easier to horizontally scale. But when you have older applications that are stateful, great place to put them in containers. Public cloud portability, allowing me to take my container from one cloud to the next because you've got a common specification called run C. And then software vendors. you're shipping software or you're buying software from a vendor, they're going to likely ship things on a container. So these are the typical use cases we see from the industry perspective on when to use containers. Does that make sense? Anybody have any others that maybe are not on this list? I don't claim this to be complete. There might be things missing. So I'm really, opening up if anybody has anything else they think containers would be good for. You want the box? Yeah.
Well, not really, but I had heard other people saying that when they're working on developing a statistical application or some other things that lend themselves less to version control, that they'd use a container as sort of a proxy for version control.
I would want to hear more about that.
Yeah.
I'm not quite sure how to digest that right off the top of my head, honestly.
Might be a bad idea, I don't know, but that's what they were saying.
Yeah, interesting. So we talked about containers. Now we got to really get back to the bigger problem or bigger question. If we want to deploy containerized applications to production, how the heck do we do this, right? So the first thing you could do, and I'm going to go back to my philosophical section on what workloads, figure out what your workloads are first, right? Assuming that you have and you still have containerized applications to do, the first thing you do is you could do it yourself. I don't recommend this approach, and neither does my friend. Building a platform as a service is very, very, very difficult. There's software out there to do that, both open source and commercial. So don't go that route. Don't recommend it. There's Docker Enterprise. I was talking with a client yesterday about Docker Enterprise, and they're running into some challenges, but it's working for them. All right, so there's Docker Enterprise. Mesosphere is probably going the way of the dodo bird, likely is what we're seeing, because Kubernetes, if you're anywhere near containers, Kubernetes is the big thing, right? And containers are Kubernetes have it. In fact, Pivotal has a Kubernetes solution as well. Platform as a service. Now, this is when you start looking at your workloads and say, hey, I want to deploy applications and not containers. Then I'm going to look at something like Heroku or Cloud Foundry or Beanstalk or OpenShift or even capabilities built in some of the other public clouds, right? So again, it goes back to your workloads. What are you trying to deploy? And of course, Pivotal has a solution to this problem as well. So Pivotal Cloud Foundry is a platform that runs on any cloud. For here, I'm going to emphasize AWS, right? But the idea here is that we've abstracted out the underlying IaaS from everything else. So now I could take the technical reasons for why we can or can't run a specific IaaS off the table. So now we can make it a business decision. We need to run this in China, or we need to run this on-prem, or the business can make that decision on where it should be deployed. From the infrastructure perspective, all we're looking for are virtual machines, storage, and networking. That's it. Once we have those capabilities, we then can automate or create distributed systems through an open source tool called Bosch. Bosch is really, really powerful. And what it does is it sets up these distributed systems. So think about what it takes to actually stand up a database cluster, right? You get a virtual machine or bare metal, you install the operating system on it, you install the database software on it, you do some configuration, you stand it up, you rinse and repeat for all the nodes in the cluster, right? You get that cluster up and running, and then you need to keep it up and running. Bosch does all that for you. So it's abstracting your level of thinking higher to say, hey, I want to deploy a database cluster. And Bosch says, I got your back. Once we have we can deploy distributed systems, then we can deploy a platform as a service, or Pivotal's application service. This is where applications can push Java, Ruby, Go, Python, PHP, .NET Core, .NET Framework, and Docker containers even. Where you buy into backing services, where you could scale up and down. You could use auto-scaling to scale up based on certain criteria as well. Very, very powerful. The other distributed system is Pivotal Container Service. The K is a nod to Kubernetes. So when you have workloads that you need to use containers, you can package up your containers and let PKS manage them, right? So this, at a high level, is what Pivotal Cloud Foundry is. So going back to the use cases, based on what we've learned, right? Our recommendation from a Pivotal perspective is complex, non-cloud native applications, right? So that means I have something more than just a web application. I have maybe an IoT app that needs multiple ports opening, listening to get different data feeds and do some stuff in, right? Or I have a stateful application. Maybe I have some legacy that I just want to put into a containerized system. Great example. And then software vendors, either shipping software to my customers or you're a vendor shipping software to you. These are really the three big things for what we see at Pivotal for containers. So, learnings and takeaways, right? Containers are an awesome technology. I love Pivotal's products. I'm not going to, but containers are cool. There's a place for them, right? You need more than just containers, though. Containers aren't enough unless you're just happy to live on your own laptops, your desktops, whatever you're using at home or in the office, and use them wisely, right? If it's the right level of abstraction, go for it, right? There's no right or wrong. It's all about trade-offs. At the end of the day, you're trading a notion, I need the complexity, and I'm going to deal with the additional operational overhead. Or, you know what? I want to deploy applications so my developers can be more productive and gain operational efficiencies. So, quick plug. I also co-organize the Detroit Cloud Foundry Meetup. We are currently planning a Kubernetes talk in April. We're thinking the last week in April, probably the 24th. We've got to firm up a location and dates and details. And you can go to the Meetup, Detroit Cloud. If you just search for Detroit Cloud Foundry in the Meetup site, you'll find it. So we're just at the top of the hour. Here's contact information for me. Depending on timing, I'm not seeing Amy, so.
And you have your demo, too.
Yeah, that's what I mean. So I was going to go back.
Yeah.
It's 8 o'clock. I don't know if you guys end, right on the dot or not, but I'll go back to the demo.
Can I have another quick question?
Sure.
Your diagram showed number of containers in a virtual machine. How do you decide what's the right number of containers for, and
Yeah.
distributing them that? Is that just by testing or?
Yeah, it's going to be by
yeah.
testing, but I'm thinking your container management system is going to have a thing or two to say about it as well.
Mhm.
So in Pivotal Cloud Foundry, containers are what we do behind the scenes for you. And we know that you basically say this container needs a gig, and my virtual machine that holds containers is 32 gigs.
Right.
It has room for 30-ish containers on it.
Okay.
That's going to be handled by a container management system. Great question. Any other questions? Well, if you do, bring them up. I'll switch back to see how we're doing. Really? Well, I apologize. I can stay and we can watch this go. Like, I probably should have used my phone, I guess. I thought maybe, are we fighting with the video upload? I think that's,
That's happened at other meetups I've been to.
okay. So I apologize, I didn't get
That's fine. Yeah.
to show you the full Fargate AWS.
What do these different pieces correspond to? Is it just how it splits up the bits, or are there actually functional?
These are the layers.
differentiate-
These are the layers of the container image.
So they have functional distinctions. They're not just something that's sliced up arbitrarily. then
Yeah.
When you say, I see.
Like a rough comparison to a is what they are.
Oh.
Container built to kind of layer
Oh,
by layer.
okay.
That's what I've equated it to loosely.
Yeah, it's sort of like deed for your containers. So if you have like a bunch of images that are like based off CentOS,
Mhm.
and the CentOS pieces are up there once, you don't have to upload them again. They're just there.
Yeah.
I see you have a laptop. I didn't want you to.
So it dedips it on the fly, so when you build a container and then you layer on your apps on top of it, it's only gonna bring down the pieces that have changed. Doesn't have to recreate the whole thing.
Can you talk a little bit about like Docker Compose, Docker Swarm, these cluster areas, compared to the bare Docker, like when to use those instead of just go directly through one Docker file managed?
Sure. So I am not a Docker expert. I'm going to caveat that first. But Docker Compose, you can think of as orchestrating multiple containers or multiple systems that you need in order to get something running. So if you went back to the old ways of how we used to do software development, where we had 3 tiers, right? Your UI, your middle layer, and then your database. You could use Docker Compose to say, stand up your database, stand up the middle tier, stand up the UI, and bring that whole system up.
And they communicate with each other.
Yeah.
I assume.
Yeah. Docker Swarm, I can't speak to Docker Swarm. Docker Swarm. So, yeah, I don't know if anybody else in the room has any.
Yeah, that's a great description of Compose, right? One of the things about it will let you, in a very primitive way, powerful, but orchestrate multiple things. But all the knowledge of that orchestration is in your client when you push the keyboard, whoever said go. So if something goes wrong with what's running, right, it's not going to come back. So Compose is a way to quickly get things started, running in sync and maybe depending on each other, but then all that knowledge goes away. Swarm, this may not be quite right, so anybody else jump in, puts that knowledge of what you said you wanted to run up in a cluster somewhere. And then if things change, it will try and put it back to where it was supposed to be. So if services die or you need more of one service than another, Swarm is sort of an orchestrator that does the whole thing, trying to remember the state that you gave it. And so it allows you to bring up not just individual services, but services that are persistent, that will allegedly, I think it's hard to me to tell what's going on with this, but it feels like even Docker is kind of going to Kubernetes as the orchestrator of choice.
Uh-huh.
In like Docker, the latest, like the December or maybe it was in the March, one of the later builds, you can, if you're on the edge version of the Docker distribution, you can swap out Swarm for Kubernetes as the default orchestrator in the default Docker build. So they're doing full support for Kubernetes, and I'm not sure what's going to happen with Swarm. Having said that, I think it's kind of neat, and there are some great features to it. It's just that the rest of the world caught up to it, and while Docker was making Swarm great, other things happened.
Yeah.
It feels like the mind share around it's just all Kubernetes everywhere all the time. So
Swarm is the nice thing with Swarm is that it's like super simple. So if you just want to take your Compose, like what you define your like Docker Compose YAML file, and run it over multiple systems to get that whole HA, it handles that for you. But once you start actually having to orchestrate a lot more of the other like random dependencies and deployments and things like that, that's sort of when it shows limits. And that's when you start looking at something like Kubernetes.
But I would say you're right. If you don't need
Yeah.
Battleship Kubernetes, Docker Swarm is
Oh,
pretty
yeah,
neat,
definitely.
and like you say, it's the same series of commands. If you're right under the Docker command line, you sort of add like service to a lot of things, or task to a lot of things, and it just kind of works like you would hope to do. And I really thought when they added the mesh networking to it, it became really fun, because you really didn't have to care about, I've got a cluster with multiple hosts, they've all got their own IP addresses, they're all talking to each other via gossip, but you send your user somewhere randomly at one of these IPs through some load balancer that is totally ignorant, stateless, and the mesh and Swarm will make sure that, I'm not running that thing that you were looking for, but I know somebody else is, and I'm going to privately, quietly send you there, and you'll never know. So it made a lot of things super simple.
Is anybody interested in seeing how you would deploy an application to Cloud Foundry? Yeah?
Sure.
Okay.
Hey, while you're doing that, I just have a question for the room. Has anybody been allowed into the EKS preview? Anyone? I've asked for the preview, but I've not been.
You said something.
I think it's on one of our accounts, but I don't know what the anything of that.
I'm just curious.
I've seen like one
But they're real tight with it.
Yeah, but like, you still have to sign an NDA.
Oh,
Okay.
okay.
Hang on, let's
You can't,
past the.
What's Cloud Foundry versus Fargate versus Pivotals? Like, are these separate systems for handling orchestration? For
So
containers?
Pivotal Cloud Foundry includes both a PaaS and PKS, or Kubernetes. So giving you the option, so I have some workloads that I just want to deploy applications, but I have other workloads like containers that I need to deploy and manage with Kubernetes. So that's what Pivotal Cloud Foundry is. I was going to demonstrate pushing a Java application to the platform and show you that. Does that answer your question?
Yeah.
Okay. So I have an app called Spring Music, and I don't have anything deployed. I just did a CF apps just to show that I'm already logged into my vSphere in my home lab back in Howell. So I'm going to do a CF push, and what this is going to do, it's going to pick up, there's a manifest.yaml file in here. And that manifest, I could show you when it's done, just basically says it has a name called Spring Music. It requires 1 gig of RAM, and here's where to find the jar file. What it does is it then uploads the bits. Now this might take some time too. Fortunately, it looks like it's going pretty.
It's almost there.
It's almost there already, right? So it's going to upload these bits, and then it's going to go through a staging process. Because what it's pushing is just the jar file. So now the platform has to figure out what it is, right? So it looks through a process called build packs. And you can think of a build pack as a technology that handles that ability to say, okay, you want to deploy a Java app? I know how to do that, and I take care of it. That's what a build pack is. And we have build packs not only for Java, but PHP, Go, Ruby, Python, .NET Core, .NET Framework, et cetera, et cetera. So now what's happening, the Java build pack detected that it's an app that it can handle. It's downloading some bits, like a JDK and some other libraries that it needs, and it creates what we call a droplet. You can think of a droplet as a container image inside of Pivotal Cloud Foundry. Then it's going to, and it's doing all this in a container, it then kills that container and launches another container to start the application. And right now that's where we're waiting for it to start up, and then we'll get a URL where we can hit it. So that's just about there. So now my application's running, shows me how much it's using, how it started it, and it calculated all this for me. I didn't have to tell it anything. I just pushed my application. Let me show you the manifest. So I have the name, memory, random route, just gives me a nice, funky Spring Music, terrific pangolin. What the heck is a pangolin? At my domain, right? And then here's the path to the jar. So I can grab the name of the domain name here for the app, go back to here and put it in, and we'll see Spring Music come up here in a second. So by default, Spring Music uses JPA. I don't know how many people here are Spring people. If it doesn't detect the database, it uses an in-memory database by default. And so here's Spring Music application up and running. So I could spend all night talking about this, so I want to be respectful of your time. If there's things you want to see, I'm more than happy. I could show you how we could bind to like MySQL. I could show you scaling, all sorts of stuff. But I want to respect people's time. So, question?
How does it handle load balancing? Can you show us how does it handle load balancing here?
Yeah. So if I scale this up, so let me show you the Apps Manager. Come on. Still fighting. I'm kind of curious to see if that other one is still uploading. Come on.
So if it's partially uploaded and stopped, can you will it remember where it was uploaded?
I don't know. I would think not, but
Okay. I mean, it's
So-
probably pretty unusual that you get a partial upload most of the time.
Yeah.
Because the whole idea is these things are small,
right.
right? Yeah, yeah.
Well, small,
So-
relatively speaking.
Relatively, yeah.
Right? And that's
Yeah.
the other thing about a jar file is going to be a lot smaller than a Docker image, right?
Mm.
Because I don't have that other overhead. So
That's what Alpine's for, it's 3 megs.
there you go. Yeah. So Pivotal Apps Manager is where developers go to manage their applications. So I deployed that to test. Here's my application running. So if I click in on this, I can just go and I'll scale this up to 3 and hit Scale App. And what this does is it takes that droplet and scales it up pretty quick. Right? Now, probably already running. Sometimes, let me just refresh. It's really quick to start the sucker up. So I'll just do a quick refresh and we should see 3 instances of the application running. It launches so fast because I already have that container image, that droplet created, right? So I just have to put it in another container and away we go.
Manually scaling.
That's manual scaling. We also have auto scaling as well.
And who controls auto scale? Like a host somewhere?
No, you can. You can set up rules.
Rules.
Yeah, absolutely. Come on. All right, so now we have 3 apps running. So there's so many ways I can go here. Let's go to the services, and I can say new service, and I'm going to bind it to my app autoscaler, select the plan, give it a name, and hit create. So now what that did is it hooked into the application autoscaler, but in order for this to take effect, I have to restart it. Because it needs to do that, right? The way most services work is it injects environment variables into the container itself for doing things like connecting to databases. In this case, we just need to do this so autoscaler has its hooks into it. So as this scales up, then I can go in to the autoscaler. Oh, replace the test. Service. I didn't bind it. No, that's not right. In the wrong place. Yeah, it's bound. Manage, there it is. Changed it on me. We release software. Oh, so here's a cool trick. If you're in Chrome and you don't want to have to click through, type bad idea, and it gets past this. It's the best trick I've ever learned.
Wow.
Bad idea. It's a good idea to do if you know what you're doing, but. We're really struggling with the network here. Sorry about that.
So when it spun up 3 instances of that application, it called it a CPU. Now, I don't want to get really worried about the lingo, but I thought you're counting containers as CPUs, or
So no, actually, we don't deal with CPUs in
because it had
PaaS.
it on the just on the display. It just said CPU. and it
Percentage of
counted.
CPU, I think. How
I
much
thought
is
it counted
utilization?
CPU numbers 0, 1, and 2.
Oh, that's the instance number.
Yeah, the instance, but it
That-
said CPU. And that was-
Percentage. That's the percentage of CPU usage
I
for each
thought
individual.
All right,
yeah.
well, I misread it. Thank you.
Yeah, no worries. So now I've got my autoscaler. I can now turn it. I've got to edit this and say I want a minimum of 1 and a maximum of 1. And I could do other things like here's CPU utilization, but I can also do throughput and latency and set my criteria up if I want. It's easier to demonstrate scaling down than up. So I'm just going to turn this on and say I just need 1. And if I go back to my app here, we'll see in a bit that this will scale down to just 1 instance. So in the new version of the autoscaler, we've added a couple more controls. One of them is the depth of a Rabbit MQ queue. So if you're doing things with putting events inside of a message queue, and you need to scale up to handle the backlog of requests, it can automatically scale up or down based on that. And there's one other thing, and I'm not remembering it off the top of my head.
In terms of percentages, Does it instance have access to 100% of the CPU if it wants?
No,
So these are all on, okay.
they're
So
sliced
they're sliced according to the
based
the
on memory.
container
Actually.
manager. Okay, I
We
see.
use memory as the way of determining what percentage of that
Okay.
VM it should get. So I just refreshed it to show you that we should be seeing just one instance now.
I'm assuming this is going to run on or this controls multiple virtual machines.
That's correct.
This desktop. And so probably on the front end, it's going to be a load balancer, like elastic load balancer. So that elastic load balancer only talks to one machine, or
No.
what happens? How
Good.
does it, yeah.
Yeah, so you can think of paths as a black box. And typically what you have is an F5 or, if it's on-prem, or an elastic load balancer. Inside of the paths, we have what we call Go routers. All we do is we set up the routes to the Go routers. And the Go route, you can think of the Go router as knowing I've got a request coming in for my app, which container do I need to route it to? So the Go router has the information to know, oh, here's my we call them cells. Here's my container. A is running on these two cells. I'm going to load balance between those two or do a round robin. So it's one of those things that if you don't have a PaaS, right, if you're doing a Kubernetes even, you have or Docker, you're going to need to have some of these other things that you get from a PaaS. Again, it's that trade-off. It's like, if you have containers, you need to run containers, run them. That's fine. But if you're just running applications, platform, whether it's Pivotal's or someone else's, from a developer productivity and operational overhead, it's amazing.
So it shows your history of what you did there. In your
Yep.
events.
So you can see there's only one running. And you can see how it scaled it up, right, and then scaled it down. Any other questions? Thanks for staying staying late. Appreciate it.
Thank you.
If you wanna stick around and ask me questions, that's fine. But once again, thank you.